It's still December. I still have crazy festive holiday sweaters, and this IBM 5150 motherboard still isn't booting. Hello everyone, I'm Alan Gracia, and this time for part 4, let's see if we can figure out which component on this motherboard isn't working by probing around with the oscilloscope and making plans for what comes next. Okay, before we get to the IBM 5150 motherboard, I wonder how many times this month I've actually said IBM 5150. All right, never mind. Anyway, before we get there, we've been having all sorts of problems trying to get this thing to boot, and there's lots of variables. We've tested a whole bunch of things. So since I'm an IT nerd, I'm IT professional. Let's IT professional. One of the tools that we use is the Kempner-Trago root cause analysis model. And so this is a very, very stripped down version of that model. And that's going to help me keep track of what I've tested, what I've looked at, what are some possible solutions, and what evidence do I have to see whether or not something was validated or whatever. And so the deal here is that you ask, why is something happening? And then you begin to fill in the blanks as to the whys, and drilling ever more deeper and deeper until you find a most probable cause. Test your theory, and then you'll know whether or not you have your root cause. So let's just quickly run through this, and we'll use this to recap the things that we've looked at already and work on this to help us figure out where we go next on the motherboard. So we can see over here, I've said this is an equipment goal. In this particular case, an IBM 5150 Model B isn't booting, and there are multiple reasons for why that can't be booting. You might have a bad power supply, you might have bad switch settings, because the 5150 has no BIOS. Everything's configured by switches. There's a faulty crystal oscillator, you have a short on the main board, or one or more of the ICs, integrated circuits, on the motherboard is bad. And so we've looked at a number of these things already. So we know the power supply is at least functioning within tolerance because it verifies good by following the documentation on -0 degrees. The voltages are good, and under load, remember we did in one of the earlier videos, we put that power supply under load with a SCSI hard disk drive from an old Windows 2000 desktop I used to have. That fan spun up. It was, the power supply was putting out the correct voltages that we tested with the multimeter. And we had no magic smoke being released from capacitors or anything inside the power supply that we saw. So we know the power supply is at least close enough to in spec as should be to power this motherboard. And so we also know that we could have some bad switch settings, and there are two switch blocks. So we have switch block 1 and switch block 2. So why might we have bad switch settings? Because one of these two switch blocks might be incorrectly configured. And so the corrective action would be to reset the settings for switch block 1 or switch block 2. And then so we've gone through and we looked at these settings using, again, the reference guide on -0 degrees. And we know for the minimum viable testing configuration, which is the power supply, the motherboard, and the clock, and the speaker, sorry, the clock. We'll get to the clock in a minute. The motherboard, the speaker, and the power supply, right? That's the minimum testing configuration. And we know that based, again, on what we saw at -0 degrees, switch block 1 was set correctly. Also, this is a Model B version of the 5150 motherboard, which is the 64 to 256K RAM version of this board. So again, the possible solution for why one of these switch blocks might be not working is to just go ahead and set the correct switch blocks. And I noticed that here we have a mistake here. We should also have copied this down here, which would say the evidence was that we went through -0 degrees and we verified that the motherboard is configured for 256K of RAM, which was dip switch 1 was on, next two were off, next two were on, and then the other remaining switches don't matter, so I flipped them to the off position. So we know that it's not the switch blocks, because they are set correctly. So we know the bad switch settings is not likely the reason why this 5150 is not booting. We also know the power supply is also not likely the reason why the 5150 is not booting. Next, we took a look at the crystal oscillator. And so the crystal oscillator, along with the clock generator chip on the motherboard, that's chip 8284. It's at position U11. We know that those are good because the crystal oscillator was generating 4.77 megahertz signal on that the 8284 clock generator chip at pin 8, because we saw with the oscilloscope, excuse me, with the multimeter, oscilloscope, whatever whatever that device is called over there, that we were seeing the 4.77 megahertz signal. So we know that was good as well. Now, I did put that thing through an ultrasonic bath, and there was some discussion online that perhaps a crystal oscillator going through an ultrasonic cleaning could kill the crystal oscillator. So we're going to leave this one suspect for now because I want to make sure that it wasn't a good crystal oscillator and then I killed it by putting through the ultrasonic cleaner. The good news is if I did kill it, I do have 2 spares, which I recently purchased online, and so I have them in inventory. So if there is something wrong with the crystal oscillator, we could swap it out. And if I screw it up while I'm swapping it out, I have a second crystal oscillator which I can swap in. But I hope we don't have to do that. So we do need to double check that. The crystal oscillator right now is still suspect. Next thing up, we could have a short on the motherboard, and so we might see that as incorrect voltages at the motherboard connector, right? That's the connector at P8, P9. So we have a couple things that could be going on there as well. Or there could be a short on the motherboard, and which could lead to something like a bad tantalum, where you have, I don't know why I have short circuit on the motherboard twice, but anyway, we could have a bad tantalum capacitor. I'm going to be incapacitated by the time we're done with this. We could have a bad tantalum capacitor in here as we go through. So how do we know? Well, we could buy more tants from Mouser.com. But we have some evidence that the capacitors are okay because the PSU, the power supply unit, does not short out shortly after turning on the CPU, after turning on the power supply, and we don't have any tantalum caps that tested as being bad ? Because I still don't know 100% if I'm doing this right, but at least in my attempt to test the tantalums while the system was powered up or while the system was powered off, everything did seem to be operating normally. We also did not have any tantalums explode, which indicated they might have gone bad or been crossed, or someone had been monkeying around with the motherboard in the past. So again, no telltale evidence from the power supply with anything shorting out. No magic smoke was released. Tantalums haven't exploded, and there doesn't appear to be any short circuits on the motherboard. Now, we could have incorrect voltages. We took a look at those P8, P9, so we could have cracked solder joints, which could be giving us faulty power, in which case we would just reflow the joints on the bottom of the motherboard for that P8, P9 connector. But the evidence that that's not the problem was using some goofy goggles, which you may or may not have seen in previous videos. There did not appear to be any solder cracks or cold joints in the P8, P9 array of pins. I did take a look at them. Again, I'm not an expert, but I didn't see any of the telltale signs, the rings around the legs, that would indicate that there was a crack in one of the solder joints. So when we come down here, we say, well, the P8, P9 voltages could be out of tolerances when the power supply is connecting to the motherboard, and that's enough load to generate for the power supply to keep going. And again, using evidence from minus 0 degrees, we took a look at the voltages coming off all the various pins involved here, and we decided that based on the documentation at minus 0 degrees, they were all within tolerance, they were good. So we don't think at this point that there was any cracked solder joints. The voltages weren't on a spec, which means the incorrect voltages, and so it means there's no short on the motherboard, there's no bad caps on the motherboard, so it's not likely that there's a short circuit. Which brings us down to the thing that I've kind of been dreading this whole month of December, which is that there is one or more bad integrated circuits, ICs, on the motherboard. So these are chips that may heat up, they may burn out eventually if I leave the thing powered on, but they're the things that are obviously not, I can just look at it and see, oh yeah, there's the problem. So a couple things could be going on. We could have a faulty BIOS chip, part number 150, 147.6 at position U3 on the motherboard, or we could have potentially a faulty 8088 CPU. Now I have the AMD version of the 8088 CPU. It is functionally equivalent to the IBM Intel CPU that's available, also 8088. So these are the two things that we are kind of need to dive into a little bit. We're going to get to the motherboard in just a minute and take a look at these, but I just want to talk about these two things next. So for a faulty BIOS chip, if the chip is in fact bad, I could try to source another 150, 147.6 chip somewhere off of eBay or somewhere else. It's probably at this point not going to be known good. It's going to be as is. So I could be chasing after these things indefinitely, looking for one that works and just buying defective parts that I cannot test. So I don't have a source of a known good replacement BIOS chip. Now, what have I done to fix that? Well, a couple things. I've gone ahead and purchased a T48 EEPROM burner, EEPROM programmer. So it's possible for me to, for the next video, go ahead and get some compatible EEPROMs or build an adapter and write my own known good EEPROM. That's entirely possible. We can try swapping those out in a future episode. But what I'd like to do today is take a look at the signals that we're seeing coming into or going out of this AMD 8088 CPU and see if we can find anything that might be coming up there that would indicate that there is a bad chip, whether either with the 8088, perhaps with the clock generator, 82, 84 clock generator at U11, or something else downstream of the 8088 CPU. So let's get over to the other side of the desk and let's take a look at the motherboard and figure out where we go from here. Okay, with the PC powered up, let's go ahead and do a quick sanity check. We'll make sure the clock generator on pin 9 is still showing a valid 4.77 megahertz clock signal. That is required to make this all work, and well, let's make sure after the ultrasonic bath that it still does. So we'll go ahead and here on the oscilloscope, and yeah, 4.77 megahertz. The crystal oscillator and the clock generator chip appear to be working perfectly now. Okay, so that's good. So we know the ultrasonic bath did not damage the crystal oscillator. So next, let's take a look at the CPU, which is right here on the motherboard. This is at U3 on the board. And let's take a look at pin 19 and make sure we're still getting that same 4.77 megahertz signal. And we touch. Well, I'm not showing a frequency here. We are getting that same signal. Right here's the clock generator. And then we'll take a look at the CPU, and we're looking like we're getting that good signal there. Interestingly, the bus driver, the chip here at U6, the 8288 is remarkably hot. So that's probably not a good sign with that thing getting so hot. What else is getting hot on the motherboard? The CPU, the 8088, is very, very warm. BIOS chips are cool. Memory chips are cool. But the CPU, if I can leave my fingers on it for more than just a few minutes, a few seconds, it is hot. The clock generator is not, it's warm, but it's not super hot. And the driver chip here is also very, very hot. So that's an indicator something is not quite right here. So while we're still going, let's take a quick look at this chip, and we'll take a look at a couple of things and see where we are. Let's see if the computer has come out of reset. That's going to be pin 21, so that's 20, and then pin 21 is going to be over here. So let's take a look at what we got on pin 21. And that is not high. So it's active high. So that's low. So that's looking pretty good. Let's turn off the computer. And you should see it go high briefly and then come back low. There goes high and then low. Okay. So we know the computer has come out of reset on pin 21. Let's take a look for whether or not the CPU is inactive with the hold and hold acknowledge. That's going to be pin 30 and 31. So if we look, you can't see this on the screen. I'll drop the chip description in here. But pin 31 is hold, and 30 is hold active, and 31 is hold. And if we're high on either one of those, the CPU is being halted and will not execute code. So that is another possible reason why the CPU will not boot. So let's quickly take a look at this. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Pin 30 is high. So that is an indicator that we're in hold state. And pin 31, hold acknowledge, is also high, right? So 30 and 31 is hold acknowledge. That means this CPU is being told by something on the board here that there is a request for control and that the CPU should go idle. So with the 30 and 31 both high, the system's not going to do anything. Let's take a look through working through the data sheet. Some other pins that we want to take a look at. Pin 33, we should be in maximum mode for the CPU, and that's going to be on pin 33, and maximum should be low. So counting backwards from 40, 40, 39, 38, 37, 36, 35, 34, 33. Lost it. Do it again. Sorry, folks. 1, 2, 3. That's 40, 39, 38, 37, 36, 35, 34. Pin 33, keep sliding off the pin, is low. So that is MX mode for the CPU. So that's the mode we want it to be in. Let's make sure that the CPU is in its ready state. So that's going to be pin 22. And it is active high when it's in ready. So 21, 22 is right here. It's high and then drops low. So that is not what we were expecting. If the computer was in its state that it would be ready to execute code, it would stay high on pin 22 for the ready switch. So that's kind of suspect. What else do we have on my notes sheet here? We want to take a look at the interrupt connection on pin 18. So if this is 20, 19, 18, it's low. And looking at my cheat sheet here, its interrupt is active when it's high, so we're not seeing an interrupt coming across. And then let's take a look at pins 26, 27, and 28. That's going to give us the status symbol, and it's a 3-pin sort of a truth table, if you will. I'm not sure the correct term of it, but when we should be in some mode where we are reading or writing I/O, accessing memory, perhaps, but we don't want to be necessarily in a halt state. So let's take a look at that. So pin 26. So again, we have 21, 22, 23, 24, 25. Pin 26 is high. So that's the S2. So it's high. And then 27. Pin 27 is also high. And then what do we have for the final pin? 28. 28 is also high. So pins 26, 7, and 28, which are the S2, S1, and S0 codes. Based on the table here, we see all three are active high. The CPU is passive. So I think that conclusive, and the CPU is getting really hot. Same for the bus driver. The clock chip is getting warm. I don't notice any other chips getting hot. RAM is all cool. The parity memory is cool. All the chips in the upper, what's in my upper right hand over here, all cool. These other AMD chips are warm but not hot. So there is something going on in this area of the board that is not kosher. All right, it's been a couple days. For continuity, I have the same red sweater on. And I've been reading some data sheets, talking to some more folks online, drinking more Janka. It's all good. And I want to go ahead and take a look at a couple more signals on the board so we get a feel for where we are with things. And then we'll wrap it up and bring this Dawsember to a close. Okay. So let's take a look at a couple things here. Let's check on the processor, the 8088. We're going to take a look at pin 25. So that is the auto latch enable. And yeah, the ALE is the address latch enable. Excuse me, not auto latch enable, the address latch enable. So we'll take a quick look at that. Let's just, for continuity, we'll come here. Pin 19, we're still seeing good signal here. So we'll take a look at that. Pin 25. 1, 2, 3, 4. Pin 25 on the 8088 CPU. There it is. So we're seeing that signal. Nice little square wave going on. That's looking pretty good. That's kind of what we're expecting here on the oscilloscope. So now we can follow that same address latch enable over to the bus controller, the 8288, which is up here. And that's going to be pin 5. Let me bring up its data sheet so I'm reading the right thing. All right, pin 5 is the address latch enable. And this is going to strobe high. 1, 2, 3, 4. Pin 5. There it is. So that's looking good as if I can stay on the pin while I talk here. 1, 2, 3, 4, 5. There it is. So that's also looking good. And then we'll take a look at AEN, address enable. That's going to be low. It's going to be active low when it's on. So we'll take a quick look at that. 1, 2, 3, 4, 5, 6. And we see most of the time it is low. It is pulsing there with popping up high a little bit. Let me see if I can capture that with the trigger. Can't quite grab it. But you can see it here in the video. It is pulsing, and then it drops low. So that looks like it's doing what it's supposed to do. That's the 8288 bus controller. And the last thing we'll take a look at is the multi-timer, which is 8253 at U34. And we're going to take a look at 8253, bring up its data sheet. And we're going to look at pins 9, which is the clock 0. And then we're going to take a look at pin 10, which is the out 0. And we should see some square waves on that chip. So here we are, and pin 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, we've got a nice square wave at 1.1 megahertz. Not quite sure if that's a megahertz, but I'm sure it's not megabits. So 1.19, 1.2. A nice square wave there. That's looking really good.
And we'll go over to the next pin, which is pin 10 for out 0. And that thing is kind of flickering. It's coming up high, and if you probably can't see it in the camera here, but it is trailing low, and sometimes you can see a very faint line as it crosses high to low. But that does not look like what I would expect to be here. I was kind of expecting another square wave, and I'm not getting that.
Okay, so let's take stock of where we are. First of all, I've gone and learned some new tools on how to record overheads and multi-angle cameras and all that stuff, and it's been kind of fun learning those new tools and using them to edit and create these videos. So it's been a nice experience with that. Speaking of tools, I've gotten to start working and learn how to use the Zoe multimeter oscilloscope. So it's not just, yeah, I have one and I can test for continuity. I'm using it, and we're using it to trace, check for broken traces, check voltages, looking at the oscilloscope to see signals on the motherboard. That's all new skills, and I'm glad that I've been able to at least start using and developing those skills. Again, I'm pretty sure most of the folks watching this video already know how to do all that stuff, but it's been interesting and fun to learn how to do that. I've got a T48 EEPROM programmer, so I want to spend some time and get to know how to use this, because we may need to create a new BIOS ROM or the basic ROMs. Those, we don't know yet if these are in fact good. So we might still need the T48 for this project. And just earlier today, I've got an inexpensive logic analyzer that showed up, which will also help diagnose and track signals that are going on the board here. So we can try to figure out where in the post process, the power on self-test, this machine may be falling apart or falling down or getting stuck or whatever. So hopefully between the oscilloscope, the multimeter, being able to write new EEPROMs, and the logic analyzer, that those three sets of tools will help me figure out what is going on with this 5150 motherboard, so we can repair whatever's messed up or corrupted or not working, and finally get this 5150 booting. And this project really just has reaffirmed for me how amazing this retro vintage community is. The folks here are just absolutely fantastic. From folks who have been helping me privately to Glorious Cow over on Blue Sky and Mastodon, just taking a deep dive with me into what's going on with these chips and what kind of signals to look for and all that. I really do appreciate their tips. Big Bad Biologist done a fantastic job pointing me in directions. And just everybody who's been commenting on YouTube and Mastodon and Blue Sky. I really do appreciate all of you. All the likes, the subscribes, the comments, all of it. It just encourages me to keep going when I have a project like this where it just seems like I can't get anything to actually work. So you guys are just, and gals, are just fantastic. Looking forward to seeing you all the next VCF East. And as we come to a close for December 2025 and 2025 in general, what's next? What's going to happen? Well, since it won't be December tomorrow, the 5150 is going to take just move over on the desk here. I'm still going to continue to work with it. As I said, I'm going to learn how to use these tools, read some data sheets, schematics, work with some folks, see if I can't figure out what's going on. But that doesn't really make super exciting content if you're just watching me read data sheets and fumble around with tools I don't know how to use. So I'll be doing that stuff in the background. I do want to get the $30 Facebook Marketplace Mac Classic back on the desk here, so we can take a look at getting the broken solder pad repaired and getting that machine finally recapped and booting. Unlike the 5150, I have plenty of compact Mac Classics, SEs, SE30s. Right? I have other chassis that are known good working, so I'll be able to test that motherboard and hopefully get that cleaned up and worked up and going relatively soon. And then also I've got some ideas for more content for Marcintosh and April 2, or April Apples as it's I guess known now. So we're looking forward to seeing all that. And as I mentioned, I'm going to definitely want to meet up with all of you at VCF East this year. So as we bring December and 2025 to a close, I want to thank everyone who has participated and just watched the videos this year and clicked the links and just had a chance to chat with me online and social media. It's really been appreciated. I appreciate it very much. I thank you for watching, and I'll see 64 you in the next one. Did I just say I'll see 64 you in the next one? What a weird thing for an Apple guy to say.